So today we are starting from the context diagram. Context diagram shows all the direct system and human interfaces to system within a solution. So whatever systems are people are communicating, some customer is coming in, interacting with the system and all that. This all is shown in the context diagram. Context diagram shows the in-scope system or systems and any inputs or outputs, including the systems actors providing the or receiving them. So anybody who is getting something out of the system or giving something to the system, this all communication has to be recorded in form of a context diagram. The context diagram typically shows the system under development in the center of as a circle. So the main system is in the center. Interfacing systems, all other systems which interface with this system, which we are trying to design, as boxes, human actors as people, shapes are boxes. It can be a silhouette of a person or a shape or a box, and lines connecting them to show the actual interfaces and the data passes between them. So lines will be actually the data. Context diagrams are sometimes referred to as level 0 of a data flow diagram. Ultimately, this context diagram will evolve into the data flow diagram. So we can call it a level 0 data diagram, data flow diagram. But data flow diagrams will be later discussed in a later topic 4.10.10.2. So this is how a context diagram may look like. As we were talking about the mobile application, the mobile application we are trying to create is shown in the center of it, and around it we have got a number of boxes which are interacting with this mobile application. So what are the various boxes? The grocery shop itself is the biggest box we have, and we are doing what? From the mobile application we are sending the product availability to the grocery shopper. Sorry, grocery shop, no, not grocery shop, but the grocery shopper. And shopper is selecting the store, and he is asking for the recipe, and he's providing the login or the user credential. As a result, the product location in the selected store is sent back to the grocery shopper. Now, mobile application it receives the print ad layout, and with GPS system, what it does it sends the current location to the GPS system, and GPS system sends the local store uh, GPS coordinates to the mobile application as if it can be communicated to the shopper. The physical shelf layout in the store is sent to the mobile application, and loyalty program is sending in all the promotions to the mobile application, and interacting with all of these various other systems. This mobile application will be designed. This is the context diagram in which the whole interacting systems and people are shown here. So as far as the people are concerned, there is only one person, that is a grocery shopper. Loyalty program is a system, print layout is a system, GPS is a system, and shelf layout is a system. As we were discussing the same example, so it displays the interactions between the mobile application system being developed and external entities, similar to the ecosystem map in concept, because it illustrates data transfer or interactions between the systems, but it includes more entities than just systems, such as grocery shoppers. So people are also shown here, and it only includes entities that directly interact with the system being developed. You see, in ecosystem, we were interacting with indirect connections also. Here, we are only concerned with the directly interacting systems. For example, the inventory system sends information to the shelf layout system, and therefore we are not interacting with the inventory system. Both systems are included in the ecosystem that was there, but only the shelf layout system is in the context diagram, as it has a direct interface. The usage of context diagram are particularly useful early in the project to specify the scope of the project, including any interfaces that have to be developed. So what all other lines and links between various systems and humans, they have to be defined, and those interfaces have to be developed. It also shows all of the external touch points between the system under development and the other systems are people. Context diagrams are also helpful in determining where there could be interface requirements or data requirements. Context diagrams has begun to be used by business analysts more broadly, that is to model business user or data context, because context diagrams are easy to build and understand. So this is not something digital. This is something which can be developed by anyone for any kind of system. Context diagrams can also model the as is and to be states in order to help with gap analysis. So you can have the current context diagram and the future context diagram. As is the current one and to be is your desired one, and then you can talk about talk about the changes it has to go through to bridge that gap. So gap analysis will be done, and ultimately then you can design the new system. Relationships to requirements. Context diagrams do not specify requirements but summarize the product scope and related information that are analyzed to identify requirements. Because context diagrams are used to specify all of the interfaces, these diagrams can help identify when interface requirements need to be elicited. For example, system and human interface requirements. This model often leads a system business analyst to create system interface tables, user interface flows, display action response models, or other interface models that help to specify interface requirements. Then is a feature model. A feature model is a visual representation of all of the features of a solution arranged in a tree or a hierarchical structure. The structure can be horizontal or vertical. A feature is a group of related requirements described in few words. Most projects have features at varying levels. The top level features are called level 1, L1 features, followed by L2 features, and so on. Most feature models will have 3 or fewer levels of features. A given branch of feature model always has a feature at the end of it, with lower level features hanging off the branch. So it is something like a WBS, but it is more of a product breakdown structure. So this is a feature model. So look at the diagram of the feature model. It is again like a tree. So mobile shopper is my customer, and mobile shopper will have these 4 or 5 features. He will have a recipe, he will have a loyalty, he will have card, guide, and list. Out of the loyalty, what all sub features he has? Loyalty feature has discounts, points, referrals, and specials. In recipe, he has daily specials, create, and search. Meaning what? He can create new recipes. He can search. So what can he search? So that can be further. Third level is he can search history, he can search popular things, he can search cost, he can search according to the category, he can search according to the main ingredients. Similarly, when he is trying to create a new recipe, he can enter that recipe or he can import that recipe. Moving on to the card, he can change the quantity in the card, he can add something to the card, he can delete something to the card, he can send the online order. If we look at the list, he can again add something to the list, but it is not in the card. This is something he has added to his interest. But later on, if he logs into the card, then it will be charged. He can delete something from his list. He can put something in favorites for future use. He can search something. He can find the history of the previous lists, verify in stock whether these items are present in the stock or not, and he can add it to the wish list. Similarly, guide, we have got there can be a guide map or the location map, location guide. So location guide could tell you, indicate the store or a zip code or maybe the find the nearest store near you. The map would show the list overlays and recipe overlays. So you see all the requirements, all the features uh, are divided into a tree like a work breakdown structure or whatever you want to call it. It is like a branch of features. So one single feature, the mobile shopper could have these 5 features, and each feature has sub features and sub features. This demonstrates features for a simple recipe box solution. This feature model shows level 1 features such as list, recipe, and guide, etc., with the respective level 2 features. For a few of the level 2 features, there are level 3 features also, but it is not necessary that every level 2 should have level 3 features. It may or may not have. The different choice of font color is in this diagram is used to denote the scope. For example, list recipe scope are included in the current iteration, and the rest features in the light gray are for future iterations. You can see if you look at the diagram right on top left corner, cart and loyalty are in gray. Cart, loyalty, and list are in the gray, whereas the guide and recipe they are black. So the different color shows uh, that the list, recipe, and guide are included in the current iteration. List, recipe, and guide. This is the bold one. And the remaining two things are for future iterations, not in the current iteration. Feature models can be embellished using colors or patterns to indicate scope. You can color them, you can make them more beautiful, more understandable. One color should be used to show what is in scope for the current release, and another color should be shown for out of scope items. Usage of feature models are helpful to show how features are grouped together and which features are sub-features of other ones. Feature models are useful because they can easily display up to 200 features across different levels on a single page, which may represent an entire solution's feature set. So all the requirements, as far as the features are concerned, could be built into one single page. Relationship to requirements. Feature models usually do not show requirements but rather sets of requirements which are called features. Feature models help to determine how to organize requirements for business analysis efforts or lay out features in a requirements document. The features found within a feature model may also be used to trace requirements to ensure that no features or requirements are forgotten. That is use case diagram. Probably you have already mentioned you are using it, so you know better, but I will just try to endeavor to explain it a bit. A use case diagram shows all of the in-scope use cases for a system. You see, every tool we are discussing, every model we are discussing has a different purpose. They may look very similar to each other. They may look very, very similar, but they have all different purpose. So here we are only talking about in use case diagram in scope use cases for our systems. In a use case diagram, a use case is represented by an oval with the name of the use case within it, as shown in figure 4.6 in the next diagram. An actor is shown as a stick figure. As I said earlier, we could use people as a silhouette diagram or something. So here, the actors, the people, are shown as stick figures, like people made of matchsticks. Straight lines in the diagram associate the use cases that the actor interacts with. The association does not represent the flow of information into or out of the use case. The association merely establishes a connection that shows this actor is in some way associated with the use case. Use cases are further explained later in 4.10.8.2. So here it is. There are a number of oval boxes in front of you, and these all are included in one use case, like the select recipe, submit recipe, edit recipe, reject recipe, find recipe, review recipe, and publish recipe. So there are two sides to it. One man is the user and one man is the reviewer. The user is selecting different recipes. He's finding recipe items. He's submitting his recipes, new recipes. He's publishing his recipes, and he's editing the recipes. On the other hand, the reviewer is, responsible for, the publishing of the recipe. Once the user has submitted a recipe for publication, that is vetted by the reviewer, and only when that is vetted, then it appears on the program. He can even reject a recipe, or he can review the recipe. So he can do three things: review the recipe, reject the recipe, or publish the recipe. So this is an example of a use diagram. It shows a use case diagram with a sample set of use cases for the recipe box. Uh, Use case diagrams can be used to summarize the scope of a solution, highlighting the main features to be added, the use cases. So each one of those are the use cases, whatever features you want to add in it, Each oval box is a use case, and that means the actor is having 5 use cases and the reviewer is having 3 use cases, whereas actor and reviewer are sharing one use case, which is the publishing of the recipe. Use case diagrams can also indicate use cases that are out of scope, which is helpful to manager to manage stakeholder expectations. You can convince your stakeholders that this use case cannot be included and this is out of scope. Relationship to requirements use case diagrams help the project team plan and track progress in building a solution. These diagrams help to summarize the scope of features and the relationship of features to actors. Use case diagrams do not show requirements but help to organize requirements for business analysis efforts are laid out in a requirement document. So you see, all of these tools are for specific purpose. In some cases, you might be using use cases when you are doing where you are doing your job, and someone else might be using a different tool, which is more appropriate to that specific environment. Coming over to the process models, I would like to ask you if it is all right with you so far.
Can you repeat the question?
Is it all right so far?
Hello. Yes, sir. Yes, sir. I understand the use cases, and I think use case is very limited information.
Yes, of course.
However, we what we discussed, uh, other flows that has more information, and we go into the small things to
Exactly.
understand it.
Different tools will have different levels of detail. So use case is a very
Mm.
basic kind of a tool. And
Mhm.
this use case you have used just now, we are going to reuse it in process model. Just in front of you on the screen, you can see the process models describe the user or stakeholder elements of a solution process or project. And we have got process flows, we have got use cases, and we have got user stories.
User stories. I'm more interested in user stories because I have not seen how it works.
Okay, okay, I'll explain that to you.
Yeah. But we will discuss all, right?
Yeah, of course. So, first of all, the process flow. Process flow, also called swim lane diagrams. Probably you might have used it. I have used it in my times. Swim lane diagrams are process maps, are process diagrams, are process flow charts. They're different, with slight differences. This is the same thing. Visually depict the tasks that people perform in their jobs. Typically, a process flows describe the steps that people take, although they may describe system steps and could be called system flows. In process flows, boxes depict steps. Diamonds indicate decision logic, as you might have understood already. And arrows show the order of flow. This is very simple. So the process is in the box. If it is a diamond box, it is a decision to be taken, and arrows show the flow, the direction of flow. Process flows may also contain swim lanes. Swim lanes is that you separate the separate levels of departments or whatever to as if the processes of that specific department or sect of the group of people would be shown separately, while these various 3, 4 swim lanes of different categories of people will have arrows crossing over from one swim lane to other to link to establish a link between these various swim lanes. Which group steps together that are performed by the same person, group, or people, or system? It is helpful to describe only people or system process steps in a given diagram to reduce shifting the context for the reader between the human and system processes. Process flows are developed to model the as is processes. So we establish the as is process, how the system is currently running. So we try to map it, and that map is the process flow. But we also can create to be process flows in an organization as well as the to be processes, proposed process revisions, are new proposed processes. Example in front of you, it shows the process flow for creating and sending the daily recipe for the recipe box application. This process flow has 2 swim lanes. the customer swim lane and the store representative swim lane. Just look at the store representative swim lane. He creates a new recipe, then stores new recipe data, then emails new recipe to the customer as well as inform the stores of the product to put on sale. And then there is the job of customer. New customer will use new recipe. If yes, then select recipe from the online list. If no, he will select recipe from the history. And ultimately, when he finds the recipe item, he will send it back to the store representative, which is system displays store map with ingredients. This store map is coming from the sales representative, store representative. So this is the big diagram here. Process flows are valuable on most types of projects where there are people performing tasks in the solution. Process flows are particularly useful for facilitating conversations during elicitation with business stakeholders because process flows are intuitive to create and read. If you can create these flows and show them to the stakeholders, they will be very satisfied if the flow of the process is rightly depicted in the diagram. During analysis, process flows are used to identify missing features or requirements by tracking requirements to individual steps within the process flow. Process flows can be drafted ahead of time or created real time during sessions and are an easy model for business stakeholders to review as part of requirements verification. Process flows can be used to discuss as is processes for current solutions and future processes for new solutions to identify changes or gaps. Software developers and testers find process flows to be useful to provide context for a set of requirements. Process flows are also used to show key performance indicators, metrics, either the baseline or target metrics. Each KPI is shown in brackets over the steps the metric applies to. This is useful when creating solutions to replace existing solutions where there is already a performance level threshold that needs to be maintained. Relationship to requirements, process flows are an easy model for deriving requirements by consideration of the functionality or qualities needed to support each step of a business process. This is done during elicitation sessions or during analysis. So we are using this method while we are interviewing, while we are eliciting the information. When requirements are already specified, these can be traced back to the process flow steps to see if there are requirements missing. So if the process flow is already existing, we can trace it back on the process flow and see if any of the requirements is not being shown or is missing. Steps that do not have sufficient requirement mapped are requirements that are unnecessary, requirements that do not support any steps in a process. They may be removed, new may be added. Then the use cases, as we were talking earlier, the use cases describes a set of scenarios. A scenario is any single pass through a system to achieve a goal for the primary actor. So we know the primary actor here was, the the client and the other person was the reviewer. The use case is a series of activities, actions, and reactions that take the primary actor from initiation to successful completion of the goal. Textual use cases are represented in a standardized document template or in tabular form with standardized columns. It could be in a column, tabular form, or in sentences. Use cases represent the functional aspects of a system or operation and as such are not used to document the non-functional aspects of a system. For example, how fast the product should work, how durable it needs to be, what the capacities will be. So this is just showing the interaction and it is not showing the internal details or the functionalities of those features. When documenting non-functional requirements on a project with use cases or user stories, consider placing the non-functional requirements into a separate document because use cases and user stories are not going to represent the non-functional requirements. Non-functional requirements generally apply to entire system rather than a single use case. Therefore, it makes better sense for them to reside outside of any particular use case. Common fields include the name a verb phrase that indicates the goal of the use case. So explicit name should be there, and that should be followed by verb noun format. Description, a simple explanation of the use case. Actors, the roles that are actively participants in the use case. Organizational benefits describes why the use case is important to the project or organization used to for prioritization. Trigger, the event that causes the use case to start. Preconditions describes everything that should be in place prior to the use case starting in order for the use case to succeed. There are common fields which include the normal flow, the normal course of steps to move from precondition to the post condition. There's a run through the whole process. Post conditions are everything that has changed in the environment at the end of a use case. What do you get at the end? Alternate flows. This is alternate sets of steps an actor can take to achieve the goal other than what is described in the main flow. So this is an alternate flow. This is the plan B for that process. These flows are often branch points from steps in the main flow. Exception flows. Errors or disruptions in the normal flow that require an actor or system to perform a different action to respond to the exception. And what is exception? In project management, we call it change request. So whenever there is a change request, this is in UK they call it exception planning. When you approve a change request, the new plan, the amended plan, is the exception plan. These are often branch points from steps in the main flow and will usually terminate a use case. Exception flows result in failure or non-achievement of the goal. A single stakeholder may be represented by multiple roles that mirror the multiple roles that the stakeholder plays in the business. So there might be one stakeholder who might be interested in three different dimensions. So you can create three different roles or characters, actors, and you can define that, but actually that would be representing a single stakeholder. Similarly, many stakeholders may be represented by a single role. The normal flow is commonly referred to as the happy path or main success scenario. So the path which is most commonly used is the happy path. For example, it shows a use case for a mobile application that a shopper can use to find ingredients for a recipe in a store. The alternate and exception flows are referenced from various steps in the main flow to show where the flow branches. So here you can have a look at one of the use cases. There is a specific identification given to it, UC001. The description is a daily email with the featured recipes sent to the customers who have opted in the program. The customer opens the recipe box application directly on their iOS or the Android device. The customer can choose a past recipe or use the current one. With the recipe chosen, the customer chooses a store or uses a store already indicated as my store. A map of the store is displayed with an overlay showing the location of the item on the items for the recipe. So whatever recipe we want to make a pizza, all the items of that recipe, where are they lying in the store? They will be shown. So this is the brief description of this use case. The actor here is the user alone, which is customer on a mobile application. Organizational benefit is customer visits store to make purchases related to the recipe, which are high margin cooking items. Trigger is customer clicks on a link in email on mobile device or directly opens the application. Both ways, the use case will be triggered. Preconditions are recipe box application opened successfully. So the recipe box application must be running if we want to reap any benefit out of it. And the post condition is customer views the map of the store with recipe items and location indicated. Normal flow is that system shows short description of the daily recipe. Customer selects current recipe or choose a past recipe. Customer chooses to use their local store. System displays map of the store with the recipe items overlaid as icons. Customer can select icons to see item, easel and shelf location. So this is the normal flow. What can be the alternate flow? One of the alternate flows could be local store not yet indicated. So these are the exceptions. If you have not indicated the local store, system prompts for zip code for store. So if you do not have a my store thing marked already in history, then you may provide the zip code of the for the store. Customer enters the zip code. System list stores nearby to that zip code. Customer chooses a store to be my store, and it is used for recipe map. Then you can return back to the previous step 4. Other alternative could be local store not used. Whether a my store is chosen or not, you are not trying to use the local store. You want to use an alternate store. System prompts for zip code for store. Customer enters the zip code. System lists stores nearby zip codes. Customer chooses a store from the list and return to MC step 4. The exception flows. Exception 1 is selected store does not have an item for the recipe. System alerts user about out of stock items. Return to the step 5. The other exception is no stores in the zip code. The zip code you have entered, there are no stores in that area. System alerts customer that there are no stores found in the zip code and to enter different zip code. Return to AC1 and AC2, step 2. So you see, this is how a use case is written in tabular form. It is mostly text. The usage of this use case are used when there are complex back and forth interactions between users and systems. These can be used during elicitation session to discover and describe complex interactions. So once you are eliciting data, you are interviewing the person, you are getting this information, you keep noting down these points, and ultimately you form it into this kind of a use case. Use cases are used during analysis and then later reviewed with stakeholders. Similar to process flows, use cases offer context for a scenario and specifically show how stakeholders envision the solution. Use cases are helpful as a starting point to creating tests, including user acceptance testing. Use cases can be built and implemented iteratively, so they can be repeated. A use case diagram is not required where when creating use cases, but it is a quick way to visually depict which actors are associated with multiple use cases and what the full scope of a use case is. Relationship to the requirements. Use cases typically are not standalone requirements, but helps to identify functional and non-functional requirements. During analysis, each step is analyzed to look for requirements to support the step. In particular, system steps will likely have requirements traced to them. Some organizations may choose to use the list of use cases to serve as the functional requirements by passing the creation of a separate list of requirement statements. While this may save time, testing efforts are more difficult because traceability is not maintained at the requirement level. A failure of one functional requirement will cause the entire use case to fail. While use cases help to identify non-functional requirements, it is often preferred to document non-functional requirements external to a particular use case because these often apply to the whole system. The same argument we gave earlier. So for non-functional requirements, though they can be shown here, but it is always right or good that they should be separately registered. Because why? They are applicable to the whole system. They are not specific to this requirement or this use case. Coming over to the user story. User story is used in Agile for the purposes of understanding the requirement. So, user story is a statement written from the point of view of the user and describes the functionality needed in a solution. So basically, this is something like a use case, but it is kind of less formal, and it is more of a story that the user is trying to tell how he wants certain things to be done. Typically, a user story is used in an adaptive methodology like Agile, such like in Agile development. but can be used in any methodology approach. A user story often takes the format of, uh, okay, you can read the last line. As an actor, so we have actors there. As an actor, or sometimes we call them personas. In Agile, we call them personas. I want to be able to do a specific function so that I can, you know, achieve a certain business reason, business goal. So you say, uh, as a customer, I want to book a seat so that I can watch the movie. So this is a very brief statement in which the actor has been shown what he really wants to achieve and what he immediately needs to do. Immediately, what he needs to do is a function, and business reason is the ultimate goal of that. The function provides a small discrete piece of business value or function. The elements of the INVEST acronym can be applied to all requirements regardless of the format to ensure quality of the user stories. First of all, I stands for independent. Each story should stand alone, avoiding the creation of dependencies between stories as much as possible. So each story is a unique story. We do not require to link many stories together. So let each story be an independent story. So every story will uh, look at or focus on a separate aspect. Then N stands for negotiable. The story is negotiable, is subject to negotiations at all times regarding the content, priority, form, and function of the story, and becomes more concrete just before implementation. So, because we are going through the progressive elaboration, so the requirement will be refined, and we keep negotiating the user story and we keep amending it according to the requirement. And ultimately, it is formed up after the negotiation. V stands for valuable. The story only defines features and functions that are valuable to the business and that help solve the business problem. So this must contribute towards the ultimate objective. It should be calculatable or estimatable. E stands for estimable. The story should be clear enough to generate a valid estimate or lead to a discussion that will generate an estimate. Story should be smart and small. You have seen it was just one sentence. Stories should be small enough to be implemented, adding an increment of real value within a single iteration. So as soon as this story is accomplished, this small little story is accomplished, we have delivered value. And last, T stands for testable. Each story should be independently verifiable. This is user acceptance testing. It is so small a task which as soon as we complete it, we can somehow ensure that this has been done right. So it should be testable. When using user stories, acceptance criteria are provided that are used to confirm that a story is completed and working as expected. When a user story is too large to be completed in a single iteration, it is considered to be an epic. Now, this is what I really wanted to mention. If a story is large enough not to be handled in one single iteration, then it is an epic. Now, epics are decomposed further into stories. If we have got a long story which could not be accommodated in one iteration, we would break it down into small stories. Each story be able to be accomplished in an iteration. And what is an iteration? In Agile, we have 2 to 4 week iteration. These are fixed iterations. Your organization can select any one value. Maybe your organization prefers iteration of 2 weeks, then all the projects in your organization will have 2 week iterations. Though it is a possibility that the iteration size can be varied amongst different projects. One project has 2 week iteration, another has 3 week iteration, another has 4 week iteration. But it is not suggested that in a single project you have varying sizes of iterations. All the iterations should be equally sized within one project. By the way, as I said, normally organizations have uh, single iteration size fixed for the whole organization. Stories are used by the development team to build the product. So these stories will be acted upon, and the development team will keep accomplishing or completing these stories. And at the completion of each story, we will deliver some value. That job will be done, and the value will be delivered. For example, table 4.5, which I show now, will show one epic and three related user stories from that epic coming out. So that epic has to be broken down into three user stories. The epic describes what the user will get from this product, and the user stories describe three specific types of activities the user should be able to do. So the epic here is, as a customer, I want to go to the store and easily buy ingredients needed for a recipe. So this is the basic epic. So as a customer, I want to go to the store and easily buy ingredients needed for a recipe. Now there could be three different user stories out of it. Number one, as a customer, I want to be able to find past recipes so I can prepare them again. Or, as a customer, I want to select a store or purchase recipe ingredients so I can choose a store location that is close to me. Or, as a customer, I want to have a store map of where recipe ingredients are so I don't have to hunt for them. So you see, general purpose is same. The epic shows the basic need, but that need could be fulfilled in three different ways, and these are three different scenarios. They're just like we in use story, and earlier we studied that we have got alternate planning. So these are the various alternatives open. So each one of these will make a separate user story. Uh, Taking the first user story, that is, as a customer, I want to be able to find past recipes so I can prepare them again. So the acceptance criteria will be like customer can search for past recipes. So this should be possible. Search terms can be by recipe name, ingredient name, or date. So this is naturally going to help doing this. A search can return 0 or 1 or many results. For one or many results, a user can choose a recipe from the list. You see, for each user story, you can have more than one acceptance criteria, and all of these acceptance criteria have to be fulfilled to ensure that the user story is successful, and all the user stories have to be successful to ensure that the epic has been met. User, the user stories focus on what the user is looking to accomplish and are written from the user's perspective. They can be derived from process flows when the model is used. So these things are translatable. Anything you can show in a process flow can be converted into user story. User stories are helpful on projects because they are easy models for business stakeholders to engage in creating. In agile methodologies, user stories populate a backlog and are used as a basis for prioritizing future development. So what is a backlog? Let me explain it a bit. Uh, the roles are very different in agile. As I said, the project manager, which we know to be an authoritative or autocratic kind of a leader who leads the whole effort, who orders around, here the project manager is not like that. Here we call him Scrum Master or something like that, and he is just there to facilitate. Actually, the development team is responsible for picking the work they wish they want to do. The only thing given to them is the time. So the iteration size, if it is 2 weeks, then they are given 2 weeks and they are asked to do as much as they want. Now, from where will they pick their job? So the requirement user stories we were talking about, those user stories have been collected from the customer. The elicitation of the requirements have been done, and basically These user stories represent the functionalities or the functions. So product owner is a role here which is senior to the project manager or the scrum master, and this is normally the equivalent to the project sponsor. But this person here has a lot of responsibility. He is responsible for actually interacting with the customer or the stakeholders and collecting their requirements. Whole elicitation thing goes on with under the responsibility of the product owner, and he collects whatever he collects. Basically, that could be epics, mostly epics, and some could be user stories. So all of these things, all of the requirements, all of the user stories and epics so collected will be put into a product backlog. That the whole work of the project, all the requirements included, are put into a product backlog. This product backlog will contain everything the customer wishes us to do. Now we need to first refine this product backlog. To refine this product backlog, product owner may require the services of the Scrum Master and the development team, and they will come and they will help the product owner break the epics down to the user story level. If there is a user story which cannot be broken further, it is not an epic, we can retain it, but if there are epics, then they will have to be broken down to the user story level. We already know the size of our iteration. We have an iteration of 2 weeks in this case. So anything which takes more than 2 weeks has to be broken down into user story. So anything more than one iteration is epic. So epic can be broken down into 2 or 3 or 4 parts. So this is how it is going to be done. Uh, Now, once the product backlog has been refined, product backlog has been refined, meaning what? That they have been converted into user stories. The next important thing product owner along with his team needs to do is to prioritize these items. So these user stories have to be prioritized. The most important and the most valuable user stories, value generating user stories should be kept at the top of the list. So you will get a prioritized sequential list of all the user stories, and that is called prioritized product backlog. So we can also call it refined and prioritized product backlog. This is something which is executable. So now we have assigned 2 weeks to a team of 10 people, and we ask them, this is the product backlog, come and pick from the top as many jobs you can do in these 2 weeks. So it is the will and the wish of the team, not an individual, not the scrum master, not the product owner. Nobody can force them. The team decides by themselves, by mutual consideration, how many tasks can they do in 2 weeks. So what they will do is, say they think they can do 10 jobs, so they will pick up the 10 user stories from the top of the product backlog and take them to their 2 week cycle. This 2 week cycle or iteration is called a sprint, and sprint has its own backlog. So these 10 user stories will be put into the sprint backlog exactly in the same order we have picked them from the product backlog. The highest, the topmost user story is the most important and highly prioritized. Now what the team is going to do is going to pick one task at a time, and the whole team will work on it. Once that is done, they'll pick the next task, and they will keep doing all this until all the 10 tasks are done. Now let us suppose they could not complete all the 10 tasks in the 2 weeks period. So there is no problem. Nobody is going to ask them. They have completed 9 tasks. One task has not been started, or it was just started. So what they need to do is they have to submit it back to the product backlog, and it will take its place on the top of the product backlog. So the next team, whichever next Scrum team comes in, they will start their job right from there, and the requirement, the user story you could not complete will be their first priority, will be at the top of the list. So they will pick, say, another 10 activities, user stories, and out of those 10, the one user story which we had submitted back will also be taken over by the next team. And that's how these user stories will keep, getting accomplished. But there is a chance that you have picked 10 user stories and you did complete it in 10 days, right? And you are still left with time. Because you are left with time and you have nothing more to do, you can go back to the product backlog right at that time and pick as many user stories from there as you think you can do in the remaining time. So it is very much possible that by the end of one iteration, you would have done 14 tasks. Oh, Billy aa gayi. I am sorry. I am sorry for the interruption.
कोई बात नहीं सर.
Okay,
कोई
so
बात नहीं सर. It's okay.
this was all about the user story. Let me move on and see what next we have. As user stories come closer to the top of the backlog, these should be elaborated using relevant modeling techniques to generate enough details for development to occur, known as grooming the backlog. So, what do you mean by grooming the backlog? The product backlog, which is refined, we actually have refined it and prioritized it. This we are grooming the backlog. And the interesting part is that the product backlog, which is not being executed, meaning what, which is the Scrum team is not working on, uh, that is open for customer opinion. Anytime customer can change any requirement, so we are open to that. So they can keep changing, and we can keep grooming that backlog. And as soon as the next iteration starts, the whatever condition this backlog is, we will just pick the top few user stories to be executed by the next iteration. The acceptance criteria should be developed at this time. For additional information on creating acceptance criteria, we have to see section 6 on solution evaluations. So what is the relationship to requirements? Our user story contains many requirements, therefore it serves as a functional grouping of requirements. Stories can be traced directly to the business objective to substantiate the value of the requirements and can also be traced to elements in other models. User stories can be used to manage, prioritize, trace, and allocate functionality to release and iterations. Although user stories are not detailed, they contain acceptance criteria and express user needs. Then are the rule models. Rule models help to identify and document the business rules, business policies, decision frameworks that need to be supported by the solution. Business rules are constraints about how the organization wants to operate and are usually enforced by data and are processes and tend to be true over time. When analyzing business rule, the objective is to capture what should or should not be allowed in a business enterprise. An important aspect of analyzing business rules is identifying the source of a rule. A key element of business rules analysis is the absence of technology. So here we are only establishing the rules. So there is no need for technology. We must set the rules and regulations and define the constraints, if any, from the business point of view. So we have two things here. One is the business rule catalog and other is the decision tree or decision table. As far as the business rule catalog is concerned, A business rules catalog is a table of business rules and related attributes. Common attributes to capture in a business rules catalog include a unique ID for each business rule, the rule description, and the type of business rule. There are multiple types of business rules classifications that can be followed and references to other related documents. Business rules themselves are not processes or procedures, but rather describe how to constrain or support a behavior. Business rules catalog uh, apply the business rules apply across processes and procedures and guide the organization's activities. These rules should be written in plain language, and each row should describe one rule. So one rule per sentence. Business rules should not be nested, and each should be able to stand independently. There should not be interdependent on each other. You don't need to read another rule to understand this rule. Every rule should be independent of other rules. When creating business rules, the rule need to be correct, verifiable, and consistent. The catalog can be used to refer to related requirements or governance documents. Example: the partial business rules catalog in table 4.6, which I'll show you, shows a few business rules for the recipe box. For example, only customers who have opted in for emails will receive recipe box emails, and that no personally identifiable information is allowed to be in the email. So we have two things. Those who opted for email, only they should get the free emails about the recipe. And the number two rule is your personal identification information will not be shared by anyone, will not be included in the email. So here we do the business rule catalog. Your business rule number one is recipe email opt-in. That is, recipe emails will only be sent to customers who have opted in and have a valid email address. So there are two things. Those who have opted in, and then they should also have a valid email address, because if there is not a valid email address, these recipes cannot be sent to them. So what is the type of this? This is a constraint, and the reference is corporate email policy. The second business rule is no P2 in recipe email. P2, it is PII, personally identifiable information. Recipe email will not contain any personally identifiable information. No personal information about the name or email or whatever. So this is a constraint, and again it is according to the corporate email policy. Third rule is ingredients in stock. A new recipe will not be sent when more than 10% of the stores have a restocking status of greater than 24 hours for any of the ingredients. So it is computational, so it will keep checking the stock, and if this condition fulfills, only then the ingredients in stock will be replenished. And the references will use inventory reporting system, and that is some other system that is not exactly the system which we are building. Business rules should be maintained in a repository such as the business rule catalog. So business rule catalog is a document in which all the business rules are going to be kept. The rules need to be kept current and should be updated in the same manner as any other analysis model. The business rules catalog can be maintained at a level above an individual project, because business rules are often not specific to one project. They are maybe organizational rules or system rules, so they are applicable to bigger things. Business rules catalog can be traced to business objectives, so they can be directly linkable to the business objectives and other requirement types or analysis models in a traceability matrix to ensure that all business rules are captured. For example, decision trees help to identify business rules, so a mapping of business rules to decision trees would help to ensure completeness in this catalog. Relationship to the requirements. It is common for business rules to be identified in the normal course of eliciting and analyzing requirements. These rules could lead to functional requirements that are necessary to support the business rules. Rules also emerge in discussions of functional requirements that involve decisions. Coming over to the decision trees and decision tables, if you already have been using the decision trees and decision tables, it would be much easier for you to understand it. But these decision trees and decision tables depict a series of decisions and an outcome they lead to. Decision trees and tables are often used to model business rules. And it is kind of a thing, if then else kind of a thing. So you have two options. If you go for one option, what will you be doing? And if you go for the other option, what will you be doing? So decision trees work best with binary choices, yes and no, and decision tables can be used when more choices exist and the analysis is becoming complex. Decision trees are described in a tree of decision points where each branch represents a different choice. The far right of a decision tree, the leaves, represent the outcomes for a decision or series of decisions. Decision points in a decision tree are commonly represented as text at the branch points or in diamond shapes at the branch points. So diamond shape we use in the flow diagrams also, but in decision tree diagram, normally it is the branching of one thing into two. Decision outcomes are typically shown in boxes. So whatever is the result of a decision ultimately would be written down in a shape of a box. Decision trees are drawn horizontally or vertically. Both ways it is possible with outcomes at the bottom. So if it is vertically, then probably the things are coming from top and the bottom is the detail. If it is horizontal, then from left to right. The leaves are on the right and the thick branch is on the left. Decision tables use a tabular format. The same decision tree it can be tabulated in form of a tabular table, and there we can even accommodate more than two choices. Where the upper rows in the table represent the decision points and the bottom rows in the table represent the outcome. So the decision points are shown above and the ultimate outcomes are shown below, just like a vertical tree. Each decision point row enumerates a set of all valid choice combinations. A dash in the cell indicates that the choice does not matter in determining the outcome in that column. Each outcome row is marked to indicate which choice combination is valid. Each column of the table is a business rule that describes the set of choices for each decision point and the outcomes it leads to. When an outcome is unachievable, it is considered indifferent in a decision table. The decision table consists of four areas as follows. Condition stub, that is, lists all the possible conditions in the process or activity being analyzed. So what could be the different various conditions which can apply to this decision? Then conditions themselves indicate which conditions are met. Action step defines the possible actions as a result of the process or activity being analyzed, and actions indicate which actions are taken as a result of the conditions that are met. So example, figure 4.8 will be shown to you. It shows a sample decision tree for selecting a recipe in the mobile application. If there is a store in range and if there is inventory for the items the shopper wants and if the location of the items are available, then the map can display item locations. Decision tree can be arrayed in different forms. Below, in one approach, figure 4.9 represents the decision tree for the decision logic. So first, let us see the decision table. Both decision tree and decision table are used in the model complex branching logic. During elicitation and analysis, when a business analyst uncovers a series of if this then that statement, either type of decision model is appropriate to use. Decision trees are helpful to identify ways to reduce complex decision logic by looking for redundancies in the structure, and decision tables are useful to ensure all possible combinations of decision choices are considered. Relationship to requirements, decision trees and decision tables are used to identify and represent business rules. Both models stand alone as representations of the business rules because they can be implemented directly as a process or in development. These models can also help to identify any requirement related to supporting those business rules or the specific outcomes. So here is the example of a decision tree. So select recipe, that is the action you have taken. Now you have a decision. Stores within preference range. Are there any stores? Are there no stores in the range? If there are no stores in the range, notify the user of number of stores. And if there are, then inventory available for all items. So this is the second check. Is the inventory available for all items of my recipe? If no, again notify the lack of inventory. And if yes, then place placement information available. If the placement information is not available, again notify the user that this information is not available. And if it is, then display the store map with items as if he can go and choose those products and buy them. Same thing, if you can show in a decision table, that would be uh, the map store decision table. Rules are listed, rule 1, 2, 3, and 4. So these will be rules would be showing the conditions on top and outcomes below. Conditions were yes, no, right? Stores within reference range. So the conditions could be no, yes, yes, yes. Inventory available for all items. So why is it so? No, yes, 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 because uh, the first condition could be no, the second condition could be yes, or vice versa. So placement of information available is no and why. Outcomes, notify user when no stores within preference range. So there is an X in front of it. Rule 1. Notify users to lack of inventory. Rule 2. Notify user that data is unavailable. Rule 3. Display store maps with items. Rule 4. So these are the actions to be taken. These are the outcomes. So when do you notify users when no stores within the preference range available? That is, in case stores within preference range. Answer is no. If there is no store within preference range, then you will notify the user that there is no store in the preference range. Okay, what is the second outcome? Notify user of lack of inventory. When are we doing that? If the store was in range, but inventory was not available. In that case, the inventory message will go out. Third is notify user that data is unavailable. So store is in range, inventory is available, but placement information is not available. So this message will go in that case. And if everything is available, then display store map with items. So all the decisions you have seen in the decision tree are now shown in the decision table. Exactly the same decision. Okay, are you with me on this?
Yes, sir. I understand these two items as well. I have a question that how we use these rules? Do we plan on document or how do we use?
This is very simple actually. You have created the decision tree. I hope there is no difficulty in creating the decision tree.
Mm-hmm. No, no,
So once you
it's
have
easy.
once you have created the decision tree, you would know what are the decision points or what are the outcomes. The gray boxes, I'll show you back. The gray boxes are the four decisions. You see, these are the four
Mm-hmm.
decisions. You see,
Mm-hmm.
if you can see my arrow, this decision
Mm-hmm.
notify user of lack of inventory. That would be when
Mm-hmm.
the first decision is yes and the second decision is no.
Mm-hmm.
Okay, let's see when the notify user that data is unavailable. Just follow this. First decision is yes, second decision is yes, third decision is no, right?
Yes.
If all the decisions are yes, then we reach here display store map. When the first decision is no, then we reach here. So this is pretty simple. You are just
But
plotting the same thing.
it's same like a flow chart. Is it? Is it this? This is like what the flow chart does. Yes,
Exactly,
no, yes, no.
exactly. It is just like a flowchart, but this is a decision tree. This is number of decisions, one after the other. There are no processes.
Okay.
The process is in the beginning, and the decisions at the end. In between, there are all the decisions.
We discussed the processes where we discussed the flow charts, use cases, and stories. Right? Those were the
Yes,
processes.
yes.
So what is the difference between the process and these decision tree and decision table? How
So you
how
see,
we can implement when we will implement you know
when
among
when
which
you have
we will implement when.
okay, when you have got so many options in front of you, and you want to decide what action to take in which circumstance. Normally, in a flow chart, you have one odd decision, right? And then a lot of processes going on behind and after that. But here,
There can be many actors as well. Yes.
there can be many decisions, but they are surrounded by many actions. Many
Mm-hmm.
processes are there. But here we have one decision after the other to make. If this happens, then what will happen? If this happens and that happens, so subsequently we just forget about the other processes. Just look at the various decisions you have to make. If you take decision, first decision, if the answer is yes, then you have another series of actions to take. And if you have to take the other decision, you have another series of actions to take. In between, you may have some processes, but ultimately you end up with another decision. So, in other words, I would say from a process flow, remove all the inside active actions and just make a chart of decisions. I hope this clarifies.
Yes, sir. Yes, sir, I got it. And one question I have related to stories. We discussed that we can create, if there is an epic, we can decompose it in multiple stories. And my question is, there is a possibility that we are not able to, correctly compose into stories, right?
No
There is a
problem.
possibility.
Yes, of course, but there is no problem in that. If you can't do that, at least you should be able to break it into a 2 week bracket. So if you have broken the epic into first 2 week bracket and the remaining thing is undefined, we don't care because the people who are working on that, on the product backlog, they will fix that.
Who
Say
work
you
on the product
say
backlog? Business analyst, right?
yes, your product owner is working on
Yeah,
that.
product owner. Product owner,
Yeah.
right, work on that. Because we actually worked on agile process or
Uh-huh.
during our one project. So I'm actually mapping with that why it we were failed to achieve achieve our goals because we every time what was happening in every iteration we are actually not able to achieve what we the business team or the project team selected. I think the main cause is the stories because I found that the stories are very, they are so much very small and they are very you can say what I saw in the example this.
Okay.
They are very
I'll
small
tell
and
you
very to
what
the
is the
point.
problem. Problem is that your team is not tuned up to understand how much they can do. They are picking the job more than what they can do. And interestingly,
Okay.
the problem with our software houses here in Pakistan is that they are trying to use agile like the normal project management. So they are autocratic in that. They are The project manager is ordering the team to do things. In Agile,
Hmm.
project manager cannot order the team to do anything. Team has to decide by themselves what they want to do, how much they want to do, right? So first
Okay.
time the team picks up the task, they may be slightly wrong, but after one iteration, they will learn their velocity. That is called team velocity.
Mm-hmm.
They would know. Every story has story points. One story has four story points, another story has three story points, six story points. So your team knows, or they think that they can conduct 24 story points in 2 weeks. So they will pick up 20, as many user stories as can be accommodated in 24 points. But later they find out that they were unable to do 24 points. They can hardly do 20 points comfortably. So
Mm-hmm.
next time, this time they have done a mistake, but now they have realized their speed. So next time they will not pick more than 20. You got my point.
Yes.
This way the thing will
Yes, I
improve.
got your point.
If
Okay,
you,
do we? Yeah, sir, can you keep it on?
I think, आप बोले?
Sir, we were actually at the business level, we were facing, very pressure because we have to be in very hurry to create the prototypes for them to, develop before, every iteration. So such issues we were facing, and
Why?
we were facing that this story is too long. So we,
Okay, if the
even
story is
although we
long,
tried it,
if the story is long, you should have broken it down.
yeah,
If a story
I
is long, that is
think
an
we have,
epic. That is an epic. Break it down
yeah.
into smaller stories.
Mm-hmm.
Even sometimes, what is done is that you have picked up 10 stories. You did 9, and the 10th story is halfway done. So what can we
Mm-hmm.
do about it? Should I leave it back into the product backlog, or should I keep doing it? I can't keep doing it because my iteration is completed. So what they do is, in that case, is break this story, which is half done, into two parts. The part which has been completed and the part which is not completed. The part which is not completed is again put back onto the product backlog as if the next team can take it up.
Okay. And we also face this such type of issues like we have lot of pressure at the business team level to complete the prototypes before every iteration, to analyze all the things what we want our development team to develop. So is it normal, or we were missing something,
You were
or I don't
missing
know.
you were missing something actually. You see, um, if you are doing 10 tasks, then those 10
Mm-hmm.
tasks your team has committed that they will complete. So the output of those 10 tasks will have to come out, and that is the expectation set. You cannot set an expectation that this prototype will come out. Why are you talking about a prototype when that is not included in those tasks which the team is doing?
So how the business analyst will convey the development team. For example, I can take this example. If I'm going to ask the development team to develop this example,
Hmm.
how I will convey that, how what will be the UI design, which field will how will user log in, use the credential, what will be seen to the user, that logins on the login screen, the user ID and password, how we will
You see,
represent this to the team.
the user
We
story
need.
will describe the functionality. You can describe that, but user story is so small and so easy to understand that it cannot be mistaken. Just to 1 to 2 days job. So how complex that can be?
Okay, I got you. You are saying that screen prototype is also a user story. Means if
Exactly.
I'm creating
User prototype should be small enough to be accommodated in one iteration. So whatever you are, creating the 10 tasks, you are creating 10 tasks. Your 10 user stories are being completed. The result of those 10 stories is your prototype. You cannot define the
Okay,
prototype
if I'm
outside of that.
so you're saying that if I am I request to create a login screen, then I will say that there will be login ID, there will be password, there will be
Okay,
forget password. So
right?
these are the three stories.
Until and unless these requirements are not fulfilled, your iteration will not be declared complete. It will be a failure. So if you have picked up this task, all these jobs should have been completed. And if they are not completed, they will be rejected. Your work will be rejected, and it will go back to the product backlog as if another team will come and they will do it.
Yes, at this point I got it, but my question is, business team has to prepare the prototype before every iteration, right?
Okay. No, 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 no. Don't confuse iteration with that thing. Business team, this is also an iteration. Business team has to develop a prototype. This is also an iteration. Maybe this is not
Okay.
one iteration, this could be 3 iterations. In 6 weeks, they have to produce the prototype. So, in 2 weeks, they will produce this much. In 2 weeks, this much and this much. So, that does not matter. If they are unable to complete it in 6 weeks, they may be able to do it in 8 weeks. Or maybe this is done in 4 weeks. This all depends upon the team. You can't order the team to do this by this date. This is unethical for agile. In
Okay, you are saying the business task is also in a separate iteration, means creating a prototype is an iteration.
maybe
This is
maybe
what you are saying.
maybe it is one iteration or 4 or 5 iterations.
Yeah, yeah.
You know,
But this
let
is before the development started,
yes, of course.
definitely, right?
Let's say the prototype is a epic, and you have broken this prototype into 5 iterations, 5 user stories, and these 5 user stories have to be done one after the other. So you are delivering
Hmm.
some of the prototype after one iteration, some of the prototype after the second iteration, and after 5 iterations,
Hmm.
the whole prototype will be complete.
Okay, got your point. Means every activity which is happening in the organization, every person in is bind with the iteration, and every work is, we are all every work is doing in the iteration.
Exactly,
Every
exactly,
task is in that
exactly.
iteration,
That is
part of
agile.
iteration.
That is agile.
Okay, got your point. Okay, thank you, sir.
Okay, moving on to the data models now. Data models document the data used in a process or a system and its life cycle.
Yes.
These models are used to depict relationships between data to show how data is related to processes and how to further help extract requirements and related business rules. So, out of this model, we will do some analytics and get more rules out of it because rules give us a discipline. They give us a mechanism to better manage our work in future. So we have got a number of ways doing it. Entity relationship diagrams, you might have heard about them. Data flow diagrams, very common. Data dictionary is a very common thing. State tables and state diagrams. So let us talk about these things one after the other. Entity relationship diagrams, also called business data diagrams, shows the business data objects are pieces of information of interest in a project and the cardinality between relationship between those objects. Business data objects are the conceptual pieces of data that the business thinks and cares about and are not intended to refer to exact data objects in a database. Business data objects represent the people, places, things, and concepts that the business cares about. Business data objects are shown as boxes, relationships as lines, and cardinality as labels on the lines. So, we understand now that in an entity relationship diagram, boxes will be the data objects, lines will be the relationships, and the the text label written on the lines will be showing the cardinality. Multiplicity is indicated on the relationship line to represent the number of times cardinality that one entity occurs in relationship to the other entity in the relationship, whether the relationship is required or optional. So we can show the number of times the cardinality is repeated, the relationship between two items or objects is repeated, and we can also show through a 0-1 relationship whether this is required or optional. Cardinality is modeled in several ways, such as crow's foot notations are the 0, 1, and n means many notation. Crow feet, like a crow has 3 or 4 fingers, so they will be numbered 0, 1, 2, 3, and so as many as they are. The method chosen is usually based on what the organization or business analyst is familiar with. So these are the various entity diagram, relationship diagram notations. Option 1 is like this is, you can see this is 0 to 1 relationship. 1 is the single cardinality. 0 to n is none up to many cardinalities. From 0 to as many as they are. 0 to 1 relationship is shown as 0, 1, none or single cardinality. 1, n, single up to many cardinalities. So what does the option 1 is probably 0 to 1. Option optional many, 0 to many. This backward arrow shows many. Mandatory one is 1 to 1 relationship, and mandatory many is 1 to many. Are you with me on that?
Yes, sir. I knew that because we have learned in our BS program.
Do you use these cardinalities in your daily life at office?
When we do something, when we are creating some ER diagram during my software engineering, I use that. For the
Okay,
business related, I have not used that.
right, right. Okay. So some ERDs show the nature of the relationship between the objects as a text label on the line, which is the cardinality. Next figure will show the entity relationship diagram shows 4 different objects and their relationship. For example, the customer may have 0 or more recipes, and will be able to obtain information from one store for a given recipe. The item location is specific to the store and would be captured as an attribute in a data dictionary. But it is helpful to note that on this type of diagram, the entity relationship diagram is a cornerstone model for a project that has a data management component. So there's a lot of data interacting with things within your work. Then probably you need to have the entity relationship diagram established, which will exactly show what kind of relationship is between two things. What kind of data does it send? Like if you have got a fingerprint identification system at your office, that is 1-to-1 relationship. Your thumbprint has been secured in the database, and you physically put your thumbprint on the scanner, and that is compared 1-to-1 against your stored thumbprint. So it helps with identifying the data that is created in, consumed by, or output from the system. This model is used to define the business data objects and their relationships to one another. The specific attributes of these objects are specified in a data dictionary. So for each one of the data item is explained in the data dictionary, but the relationship between these data items and the processes is shown through the ERD. Systems typically manipulate business data objects through functions to allow business data objects within an entity relationship diagram to be traced directly to requirements for those functions. The data objects can be traced to data flow diagrams. Naturally, data flow diagrams are the easiest thing to do. ecosystem maps we have studied, data dictionaries we know, and the state transition models. So this is an entity relationship diagram in which it shows there is one item, one store, one customer, and one recipe. The item and store has a 1 to n relationship. One item can be found in many stores. One item and many stores, 1 to n. Store to customer, right, sorry, 1 to n, it could be 1 to n, it could be n to n, it could be n to 1. Meaning what? One item can be found in one store. One item could be found in many stores. Many items could be found in one store. Many items could be found in many stores. What is the relationship of store to customer? W- There could be
Many customers.
zero customer for one store, and there could be as many customers for one store.
Mm,
Got it? The
mhm.
recipe to customer, there could be zero recipe for zero customers. There could be as many recipes for as many customers. Zero recipe for as many customers, or as many recipes for zero customers. So there are four options here. Okay, items and recipe. There could be one item with no recipe. There could be one item for many recipes. There could be many items with no recipe. There could be many items with many recipes. You understand this?
Yes, sir, I'm trying to map it, but actually I'm just mapping with the keys on the right side, but I'm not able to.
Forget about that.
Use.
Just look at the thing.
Okay.
These keys are always confusing. You see, item and
Okay.
store map this one with this one. So one-to-one relationship between item and store. One with
Yes.
the end of store. One item with many stores. N
Many
with
store.
n item and one store. N item and
Many
n store.
items into one store
Exactly.
and many into many. Okay.
Exactly. This is how you translate it.
Right.
Otherwise, you will always get confused. Then are the data
Right.
flow diagrams. A flow diagram illustrates the relationship between systems, actors, and the data that is exchanged and manipulated over the course of one or many processes. It is a model that can be used after business data diagrams, process flows, and an ecosystem map have been created. You see, I have told you it is not necessary that you make all of these models in one project or one organization. You may not need ecosystem. You may need mostly you are using data diagrams or process flow diagrams. Ecosystem, I have very seldom seen people using it. But yes, if there is a need, you must use it. The data stores, shown as two parallel lines, show where information is conceptually stored, and the process strips, shown as circles, indicate which functions manipulate or use the data, which external entities, shown as boxes, create data or consume data. The data flow diagrams show that the customer selects a recipe and store, which are used in processes to map the store and overlay the ingredients on the map. So this is a data flow diagram. So we have got stores, we have got store map information and recipes. These are three archives we have. And on the other end, we have the customer. So from stores, the data about the stores are provided. The customer selects the store from this data. So the select store process is initiated by the customer and the data provided by the stores. Once you have selected a store, the store number can be provided to the map store. The store map information, which includes the item overlay and the store map, could have been provided by map store, and this can be provided back to the customer map with item overlay. Recipe selection, the customer has done out of the database of the recipes in the process select recipe, and that recipe item has also been provided to map store. So this is how the whole thing actually makes sense. A data flow diagram can be used to describe the movement of data between actors and systems over the course of a process or several processes. Data flow diagrams identify data inputs and outputs for processes but do not specify the timing or sequence of operation. So there is no sequence, there is no timing shown. It is just the relationship. Relationship to the requirements. Data flow diagrams relate to requirements through the business data objects and processes. While requirements can be traced to the model, it is better used as a tool to help stakeholders and developers understand how data flows through the system, which then leads to identifying specific data requirements. Then we come over to the data dictionaries. A data dictionary is a tabular format and shows data fields and attributes of those fields. Common attributes include the name, description, size, and any validation rules about each data item. However, any relevant attributes can be captured in a data dictionary. Next figure will show a part of a data dictionary and shows a few attributes for the recipe, store, and items. Business rules may be described in a data dictionary. For example, this data dictionary shows store number is a 3-digit number that is required to be positive and one of the valid store numbers. So let's look at it. So in this data dictionary, we have 5 items. RM01 business data object is recipe, field name is recipe text, description is recipe informative layout, unique value yes, data type alphanumeric, length that many characters, and valid values. This establishes the rule. The rule for this data has been established. So you see, this is exactly what we provide to a database when we are putting some data into the database. Each table we provide these headings or these attributes, and that's how a table is populated in a database. So data dictionary is kind of a database. Data dictionaries are used to specify very detailed aspects of data and to capture data fields and attributes from the business stakeholders' perspective. The information captured does not need to explicitly reflect a database design. However, database designers use data dictionaries as an input to create the database architecture. This is exactly what I said just now. If you are creating a table in a database, you will definitely require to use the data dictionaries. So if you have data dictionaries ready, that can be very helpful in establishing the databases. Data dictionaries are used to capture very detailed requirements and their business rules. This is important that business rules for each data is captured. This model can stand alone and does not need redundant requirement statements. Next is the state table and state diagram. State tables and state diagrams model the valid states of an object and any allowed transitions between those states. Like you see, this item can vary between 0 to 5 or 1 to 5. So these are the various states it can change status to. State tables are in a tabular format with all of the valid states in the first column and across the first row. Each cell represents the transition from the state in the row to the state in the column. Transitions that are not allowed have cells they are marked X, are not applicable, are no. Allowed transitions are represented in cells with either yes or a description of the transition event that leads to the transition. State diagrams show exactly the same information as state tables, but it is easier to visualize the valid states and transitions by showing only the allowed transitions. Ovals are used for states, and lines with arrows show the transitions and transition events between the states. Some state diagrams are drawn by showing an initiation state and a termination state. Figure 4.14 and 15 will show this. That is an example of table and an example of diagram, state table and state diagram. Notice that the states and transitions are the same in both figures. Either model may be used to show the same information. So it is not necessary that you use both of them. You may use either of them. Both models show that a reviewed recipe can move to either a rejected are published state. The state diagram makes it easier to see how a recipe moves from a drafted to reviewed to published status. So let's see, what are the target states? We have got drafted, reviewed, rejected, published, and expired. And what are the initial states? Drafted, reviewed, rejected, published, and expired. So let us see. Uh, if you want to transfer a drafted role to a reviewed role, the reviewer reviews have to be included. All in the top row, in the top row, there are no other possibilities. A drafted role cannot be drafted. A drafted role cannot be rejected. A drafted role cannot be published. A drafted role cannot be expired. It can only be reviewed. And once it is reviewed, then it is either rejected or published. And if it is published, only then it can expire. So reviewed. If a rule is reviewed, it can because it has always been reviewed, it cannot be drafted. It cannot be reviewed. Once it is reviewed, the reviewer can reject it or he can approve it, but he can't expire it because it has yet not been published. If a rule has been rejected, you can redraft it, resubmit as a draft, and no other options are possible. If a rule has been published, then it can only expire 120 days elapse with no use. If a rule has not been used after publication within 120 days, then this will automatically expire. If it has to be created again, it will have to come as a draft. Now, if a rule has been expired, then what we do? Author edits expired recipes and then that can be put into the cycle again, just like a drafted one. Hope you are with me.
Yes, sir, I understand it.
So
I'm okay.
if you understand the table, you will be able to understand the diagram also. So this diagram is showing exactly the same thing. Once it is drafted, it can be reviewed. Once it is reviewed, it is either approved or rejected. If it is rejected, it can be resubmitted as a draft. If it is published, after 120 days, it is expired and it can again be, author can edit it and again put it as a draft. So exactly the same story which we have seen in the state table could be shown in form of a state diagram. So
Yes, sir.
usages, state tables and diagrams help business analysts specify the life cycle of an object in the solution. For example, objects that go through workflow and approval process are aided by using state models. State tables are useful to ensure that state transitions are not missed because every possible transition is represented by a cell in the table. When every cell in the life cycle is considered, no transitions can be forgotten. It is more difficult to ensure that state diagrams are complete, but much easier to quickly visualize the life cycle of an object. Relationships, state table and state diagrams are models that stand alone, do not require additional requirement statements to be developed and tested correctly. So this is not for requirement gathering. This is just to show the result. The exception to this is when the transition events are too complicated to fit in the cell or on the arrow, in which case the additional details is included outside of the model. State tables are also used to confirm or find gaps in data and processes that have been specified by other models and are used often to model business rules. Then are the interface models. Probably we should start them tomorrow. What do you think?
Yes, sir, we can do in the next class.
Right. So when are we meeting for the next class on on
Sunday.
Sunday night, right? That is fine. That is fine. Okay, then take care and see
Okay,
you
sir.
on Sunday.
Yes, sir. Okay,
Thank
sir.
you.
Allah
Thank
Hafiz.
you. Khuda Hafiz.
Thank you, sir.